building a circuit from a truth table using the sum of products method. The algorithm that I'm going to show you will take you from a truth table and will produce a circuit consisting only of the AND gates, OR gates, and NOT gates. The algorithm will produce a correct circuit, but that circuit will not necessarily be optimal, and it may not even be pretty. We refer to this approach as the sum of products algorithm. Here's a truth table we're going to use. Notice that our variables A and B, we've got two variables. Each can have two states. So 2 to the second should give us 4. Our numbers, our rows, are ordered in binary order. That's binary 0, binary 1, binary 2, binary 3. 0, 0, 0, 1, 1, 0, and 1, 1. So we're going to identify each of the rows that have a 1 for the output. And which rows are those? Here we go. It's these 3. Once we identify them, we're going to AND together each of the input variables. So this one, we're going to have A and B, and A and B, and A and B. Notice, since this output row is a 0, we do not put anything there. Next, we negate each of the input variables that has a 0 in its row. So looking at the first row, both A and B are 0. So we're going to negate the A and negate the B. In the second row, only A is negated. So we're going to just negate the A. The last row, nothing is negated, so it just stays as AB. So the question comes up, looking at the third row, B is a 0. So why don't we have a B negated over here on the far right? Well, the answer is, since there was no output, our X was 0, there's nothing to negate. We only do the negation for those rows that have an A or a B already in it. Lastly, we go back and we OR each of the items that we created. So the first item that we created is A naught, B naught. A naught, B naught. We're going to OR that with A naught, B. And we're going to OR that with just A and B. And we refer to this as the sums of products algorithm. The steps once again. Identify the rows with a 1 as an output, and then AND all of the input variables together. Next, for each input variable that is 0 on its row, you'll negate that variable. Lastly, you'll take each of the items that you created in step 2 and OR them together. So let's do one more together. Identify rows with 1 as an output. Well, that would be here and here. And put down all the variables ANDed together. Well, we only have 2 variables, so A and B. A and B. We then look on these rows, do we have any variables negated? Well, on the first row, both A and B are negated, so are 0. So we're going to negate them. On the bottom row, both A and B are 1. Lastly, we're going to take what we created, the A naught, B naught, and OR it with A, B. That gives us our Boolean expression for this circuit, A naught, B naught, or A and B. The sum of products algorithm allows you to create any circuit using just the AND gate, the OR gate, and the NOT gate. If you have any questions, let me know. Be well.